turn on your cameras. Okay, if you have wish or if you are ready to turn on. Okay, but next classes I will request, and that's must. Okay, right. Okay, we'll go today. I will discuss. Previously, we discussed about the waves lesson introductions. Okay, right. Waves lesson introductions. So we learn about what are the waves, how its origin, what is the important characteristic features of the wave, so how the energy will be propagated from one place to another place. So all those things we discussed. If you are not attend to that class, you that video is on my YouTube channel, so you go and see that video, right? So I will go for the brief discussion, a brief summary. So what we done previous day. So wave we classified into two category. One is the mechanical wave. Okay, mechanical waves, right? Then we classified into another category. What is that? Yes, electromagnetic wave, right? Okay. Now we have another two type of mechanical wave. So depending on the surrounding, thus how the surrounding molecules are behavior, depending on the surrounding molecular behaviors, we divided into the two type. One is transverse wave. Yes, good. Transverse waves. Then another one is, tell me. So you can turn on your mics anytime. You can tell me, Puta, otherwise it will be not boring. Real classroom, you can enjoy. So I am not a very rough person either. So I am very friendly. I'm very friendly with the students. End of this classes, you will realize. So I will be your best friend. Right. Okay, transverse wave. Okay, right. So that's a challenge. Right. Transverse wave. Then another one is the longitudinal wave. Right. Okay. Longitudinal wave. So we already discussed how these wave patterns will be originate. So tell me, what is the mechanical wave? What is the important property of the mechanical wave? So we divided into mechanical wave and electromagnetic wave depending on one factor. What is that factor? Yes, always your chat box is open for the answers, right? If you are nervous to put into the public chat, you can personally, I think you can select myself and direct message for me. So your all message will be welcome. Okay, so put into the chat box. So what are the factors we depending on this classification? Important one factor we consider here. What is that? Yes, very good. What is that? Yes, request a medium for propagation. Right. So mechanical wave, it requests a medium for propagation. So it needs a medium. It needs a medium. But the electromagnetic wave, today we are going to discuss about this topic as well. So it's no need to medium. No need a medium or not required a medium. Not required a medium. A medium, right? So this is the important factor. So depending on the required medium, so mechanical wave need a medium, that means required a medium. So electromagnetic wave, that's do not require a medium, right? Now we will go and see, we already discussed what are the example for the transverse wave and the longitudinal wave, right? I think that part almost clear for you. So if you have any doubt, you can ask anytime. Now we'll move on to the transverse wave. So basically we are going to see about the mechanical wave. So typically I will choose the transverse wave to see some characteristic features of the physical characteristic features of the wave. So we will go to this page number 4, and the physical quantities of wave. Okay, so this part we will discuss today. So take your tute. I think all you have this tute with you. So the key physical quantities of the wave. That is very important part, right? Okay, then we will move on to the, if we finish this part, we can do more questions. Okay, so I will go deeply with these all concepts, then we will discuss end of the session all the questions, right? So okay, amplitude, what is the amplitude? Okay, let me draw the wave. Okay, I will draw little big wave, not a small wave, right? This is a wave. Okay, I think it's more up near the right. Okay, I will draw in the middle. Okay, okay, this one. Okay, this is another one. Okay, right. Okay, so you know what are these? What are these half circle gone upward? What are the name we are using for that in the transverse wave? Yes, this is a crest. Right, this is a crest. This is a throw. Okay, throw. So we know those two part. Now we will look at about Buddha. Okay, this is very important, right? So focus these things, because if you understand once, it will be remain forever in your brain. Okay, so if you are not understood and you are going to try to memorize these things, no useful for that, right? Okay, so that's why I'm going to spend a few minutes on this discussion. Okay, right now, crest throw, you know, right? Okay, so this basically how this crest are formed. So I will explain here. I think you can see here or else here, right? You know, usually the surrounding medium particles are there. Okay, these are the surrounding medial particles. So whenever this wave propagation, okay, that means wave means some energy, right? So from one place to another place, the energy transmissions we call as a wave, right? Okay, this wave propagation or this energy propagation, it will be make some changes around this surrounding medium. Okay, around this medium, right? So that means some molecules will be go up. Okay, so some are go more up, some will be go a little bit medium height, some will go very height. Okay, then some will be go downwards. Okay, some molecules will be go downwards. Okay, right? So that the things will be create this crest and throw, right? Okay, so initially how it's created. Okay, right, now it's like this. Okay, now this initially they are in the baseline. This is the baseline. Okay, so you can think about this. This line is a baseline. Okay, so from the baseline, what is the maximum height this particle or the medium particle can achieve? Okay, so what is the maximum height this medium particle can go up or displaced? The correct term is the displaced. Okay, so from this, initially the molecules, which molecule is here, it is gone here to, and that is the one most displaced molecule, right? So that most displaced high displacement, okay, that displacement we call as a amplitude. Okay, right, this is we call as a amplitude. Right, now take your tute and we will going to write down something about the amplitude. I think you have two lines there. Okay, right, so this definition and this important points going to please write down there. Okay, right, first point. Okay, write down maximum displacement of a particle. Maximum displacement of the particle. Maximum displacement of a particle from its rest position. Okay, that's the baseline rest position. මේක තමයි initially rest position එක. Okay, මේ rest position එකේ ඉඳන් කොච්චරක් maximum කොච්චරක් displace වෙනවද? Okay, so what is the amplitude now? We can tell maximum displacement of a particle. Maximum displacement of a particle, right? From from its rest position. Okay, right. Now that's okay. Okay, then second point. Okay, the amplitude is related to the energy of the wave, right? Related to the energy of the wave, right? Okay, right. In the bracket, write down in the bracket, high amplitude indicate more energy. High amplitude indicate more energy, right? Okay, we will discuss those part in the sound lessons as well. Okay, right. So however, you should know if there is any, so I will take another wave, so that wave having more high amplitude, right? So high amplitude means the rest position, from the rest position the particle go very high. Okay, very high. So this height is very high now. So this amplitude is for the this black color wave. So this red color, this one is the for the red color wave. So which one is now very high amplitude? The red color one. So we can tell the compare the energy of this black color wave, the energy of the red color wave is high. Okay, so that is another things we can tell regarding this amplitude, right? Okay, so we will not going to write these things. Okay, draw two waves at the same time. So first we will draw these things under a given space regarding the amplitude. Okay, now I think we finished that 2 point, no need to writing any more things. Okay, first draw this wave and you can mark this amplitude there. Okay, right. So this is a crest. Usually we are telling this is a crest, and draw, then mark the amplitude. Okay, no need to draw these things. So I draw to explain. Okay, right. So please draw these things in a given space. Okay, if you're finished, please raise your hands. Right. Okay. The maximum height, maximum displacement. Okay, right. Are you guys finished? If you are finished, please raise your hands. Okay. Namar lazy lamaya. Very easy. Okay. Any Tamil speaking students here? Yes. Do you want Tamil explanations? Oh, Sinhala speaking students, do you want Sinhala explanations? So if you want, put into the chat box, then I can consider, right? Okay. Okay, I can teach all three language. Okay, so no, that is an advantage in our class. If you want to explain, take a if you want explanation from Sinhala, Tamil, English, I can provide in three language. Right? Okay. Right. Finished. Okay. Good. Now I will tell another important few things. Now this is one crest. Okay. So one crest. Okay. This is one crest. This is one throw, right? Now, if we take this one crest and one throw, okay, one crest and one throw, this is a one complete wave cycle, okay? So, one wave cycle okay, is having one crest and one throw. So we can write down one wave cycle equal one crest plus one throw. Okay, all right. So this also important. So when you are finished the drawing, please write down these things below this diagram, this figure. Okay, one wave cycle and is equal to one crest and one throw. Right, now this is one wave cycle and this is another wave cycle. So altogether, how many wave cycles are there? Two. So how many wave cycle I draw here? Two. Right. Okay. So that is another important point. Right. Now we will move on to the wavelength. Okay. Now we will go on to the wavelength. I think we didn't discuss this thing either. Right. Okay. Right. Now we will move on to the wavelength. Right. Now wavelength is distance between, okay, the simple thing. I will tell you simple thing. What is the wavelength? Length for a one wave cycle. That is a simple scenario. That means now forget about the amplitude. Okay, we already discussed this thing. Now we are going to discuss about the wavelength. So I will erase the amplitude from here. Right. Now we have, this is a one wave cycle. Okay, right. And this red color zone is the red color colored area. There is a one wave cycle. The blue color area, there is a one wave cycle, right? Okay. So length for a one wave cycle. Okay. So from here to here, right? There is one wave cycle. Length for a one wave cycle. So we can tell that is a wavelength. Okay. That length is equal to wavelength. Now simple understanding. One wave mean one crest, one throw. So wavelength is length for one crest and one throw. Okay, right. So we can symbolize by lambda, right? So wavelength is represented by the lambda, right? Then this also another wavelength. Okay, right. So this is also another wavelength. This is another wavelength, right? Now you have a space below the wavelength. I think we need two lines, so not three lines are given here. So first we will draw these things, okay? Then we will write down the definition, right? So again, you should draw this one, okay? Then if you write down these things below this image, that's okay, or is above that image, that also okay. Now what I need, you have to draw this by color. This is one wave cycle, so same color, one throw and one crest and one throw, and here also colored by different color. Then this is one wavelength, this is another wavelength. Both wavelengths should be equal. Okay, right? That's a simple definition, but I will give the actual definition, right? Real definition. Please draw and complete these things under the wavelength topic. Okay, right. Okay. Right. Okay. Most of the people asking now the link. Okay, is it finished? Right, good. Okay, so last week classes, yes, good. The last week classes, I couldn't able to see your chats neither. So my team members, they send the messages, but there's not a direct communication. So I would like to direct communication. So now today your chat is open for any time. So put any messages so I can read that and I can answer at the same time. Okay, no need to waiting for the end of the class. Right now we are in the wavelength. What I told, the wavelength is for length for a one wave cycle. So one wave cycle is one crest plus one throw. This one crest, one throw, one crest, one throw. So one wavelength. Right. Right? Some students are get confused. They are getting confused. Crest එකකුයි throw එකකුයි අතර දුරනේ. Okay. Right. Okay, then now I will draw this one. Okay. One wavelength එකක දුරනේ, right? Okay. So right. Now they will think this is one crest. Okay, right. This is a crest. Okay. They will take this is a throw. Okay. This is a throw. Okay. මේ දෙක එකතු වුණාම one cycle එකක් තමයි. So මෙතන ඉඳන් from here to here there's a wavelength. One wavelength. Is it correct? Is it correct? No, that's wrong. Why? The one crest and one throw, it should be yes, in order, because one crest and then we have to consider the most nearest throw. Okay, so these two are one couple. These two are one couple. So one boys in the London, girls in the anywhere, Antarctica or Arctica. Neither. So that's not a good one. Neither, right? Okay, right. So they should be close, very close. So very close at crest and the throw in between. Their length is we are calling as a wavelength. So this is wrong. So we will move on to the question. So we have a question in the exam, right? So please move on to the wave and the application, page number 12. Okay. Okay. Now, question number 1. Page number 12, you have a question number 1. MCQ question. That's a 2017 O-level question. So please put the answers. Carefully read about the second one. Okay, second sentence. Very carefully read. Now I am waiting for your answers. Because මේක ළමයි නිකන් අර theory උගන්වනවා කියලා මටත් උගන්වගෙන යන්න පුළුවන්. I can teach all the bloody things, and then finally you will not get anything, and then you will struggle to learn again and again. You need to learn again and again. But this is practically, we are going to see the questions and we will again come to the theory, then we will make summary sheets. So I will show some summary sheets. There's a very excellent summary sheets I will given to your senior Ayala. So they are going to sit for their exam on next Tuesday. So that all materials I will give to you as well, right? Okay, now what is the answer? Right, question number 1, page number 12. Page number 12, question number 1, 2017 O-level MCQ question. Okay, go to the page number 12, question number 1. Right, so let's read with me. The transverse wave propagate with the compression and rarefaction. Is it correct? Last week we discussed transverse wave propagate with the crest and throw. Now also we are discussing this regarding the transverse wave में crest throw. Wrong ne. So they ask about the throw. Then second one, distance between a crest and a throw transverse wave is equal to the wavelength of the wave. Is it correct? So how many of you are telling the second answer is correct? The distance between a crest and a throw is transverse wave throw. Right? Throw කියද්දී චකුරින් නෑ නේද? That's my throw. Okay? Right. How many of you are telling the second one is correct? Okay, nobody. So how many of you are telling second one is wrong? Second thing is wrong. Nobody? Nobody active with that. කවුරුත් නැද්ද? අයියෝ. එක කො හරියන්න ඕනේ කො වරදින්න ඕනේ නේද පුතා? So is it correct or wrong? අනේ come on. කියන්න. I am waiting for your answers. What is the question? Question එක තමයි then page number 12 go to your tute page number 12. Okay, question number 1 කියලා එකක් තියෙනවා. Number 1 page number 12 එකේ question number 1 MCQ. 2017 MCQ. I think there is only one MCQ in that page. Page number 12. Right? Is there any same number 2 pages? No? Wave and Day application 2017 O level. Okay. Right? Is it okay now? Okay. Right. The distance between a crest and a throw of a transverse wave is equal to wavelength of that wave. Is that correct or wrong? Yes, tell me. We have limited time today. Okay. Is that correct or wrong? That's wrong. Why? They are telling distance between crest and throw. That's if you are think superficially, that is okay. Me? Distance between crest and throw, that is wavelength. Okay. But somebody can think the crest from here, they can take a throw from here. So in between this distance also should be the wavelength. Now that is wrong. So we have to mention the crest and throw that is very close nearby, or crest and next throw. Okay, the crest and next throw. Okay, in between that distance is equal to the wavelength. So that second stem also wrong, right? Now we will move on to the next stem. Okay, then if not necessary to medium for propagate the mechanical wave, that's wrong. Mechanical wave must need a medium to propagate, right? Then we will go to the answer 4. Energy transmitted by the mechanical wave without transmissions of the substances. Yes, that's correct. Without transmissions of substances, the mechanical waves will be propagate. The energy will be propagate from one place to another place. So answer, yes, correct answer is answer 4. Okay, good. Okay, someone, few students send the answers. Okay, right. Okay. So if you are nervous to put the public chat, you can put in the direct as a direct message. Now we will move on to the next part. So we will come to the again to the wavelength. Okay, so I think you almost finished that. So we can write down. Notice not the length of crest and throw. We can take any consecutive points. Okay, any 2 consecutive points. That means so any same movement. Okay, so if you consider here, if there is a molecule here, it will be go more height here. Okay, so at same movement will be here in there in this crest. Okay, so in between these two, that length also a wavelength. Okay, right. So you can see here half crest, here half crest, and here one throw. So it's also a one wavelength. Okay, right. Now you can understand to the this also a wavelength. Okay, so wavelength mean anywhere you can find out the wavelength. So you have to consider simple thing is one crest and one throw. So then you can consider any consecutive points in between that length is wavelength. Okay, so write down the things in the given spaces. Okay, right. Distance between two consecutive points in the same phase window. Yeah, so crest nam crest, throw nam throw, right? Same phase is called as wavelength. Is called as wavelength. Okay, then write down next one. The next point. Okay, the distance between the distance for a one wave cycle. Okay, distance for a one wave cycle is wavelength. Is called as a wavelength. That's another definition. Okay, distance for a one wave cycle is wavelength, right? The next point, I think we have 3 lines. Okay, wavelength represented by lambda. This is lambda. Okay, right, represented by lambda, right? Okay, then another one, wavelength measured by measured in meter. So what is the unit we are using? Meter. Okay, right. So wavelength represented by the lambda and wavelength measured by the meter. So we should know about the international unit for the wavelength. That's a simple scenario, right? Okay, now, okay, so we have to practice and do these things, right? Okay, we'll move on to the page number 13. Go to the page number 13. You have a question number 5. The situation of transverse wave traveling on the surface of water at the certain moment. There is a question asked in the 2021 O-level question, right? Okay, so we will go for that. So question number 5, okay, page number 13. The situation of the transverse wave traveling on the surface of the water at a certain moment is shown in this figure. Okay, right, I will draw the figure here, so you can read the questions and tell me the answer. Okay, put it to the answer into the chat box. Okay, 2021 O level. Okay, right. We'll see what are the figures given here. Right. Now, they are represent here distance. Right. Now, all height should be equal. Right. Now, they are mentioned here. This height is 4 centimeter. This height is 4 centimeter. Then one of this distance of the throw 5 centimeter. Right. Now they are asking what is the wavelength and yes, amplitude. Right. Super. So yes, good. You guys answer correctly. So amplitude is this 4 centimeter. So the amplitude is 4 centimeter. This is amplitude. Okay. Then the 5 centimeter is the wavelength, not 5 centimeter. Why? We should consider one crest, one throw and one crest. Okay. So this 5 centimeter and another 5 centimeter we should consider for the wavelength. So altogether 10 centimeter is equal wavelength. Okay. So we can get the answer, correct answer 2. Okay. Right. So that is the applications of these things whenever we are learning. Okay. Right. So we should practice the questions as well. Then only it will be go to our deep memory, right? Okay, now we will move on to the next quantity, that is the period. Okay, what is the period? Okay, good. Now period is time duration or time taking to pass a one wave cycle, or time duration for a one wave cycle. Simply we can tell. Okay, now take a wave. Right. So I take two wave cycles are there. So now I will tell the time. Okay. So from here to here, the time is, I will tell the time is here from here to here, 2 seconds. Okay. Right. Now, how many wave cycles are there? Two wave cycles. So what is the time duration for one wave cycle? What is the time duration for one wave cycle? So one wave cycle taking 1 second. Why? The 2 second for two wave cycle. So one wave cycle taking 1 second. So one wave cycle mean one crest and one throw. So this is a period. So it take 1 second. So that is equal for period, that is represent as a period. Okay, right. Now draw this image. Draw this figure in the given spaces below the period. Okay, so draw small. Yeah, I have to write down another two formula also there. So take minimum space. Okay, right. Okay. Okay. Super. Okay. Right. So if you're finished, please raise your hands. Now we will write down the definition for the period, then we will come back to another few things we have to write down there. Okay, right. So please write down these things. Okay, so you have spaces below the topic of period. So write down there time taken for one complete wave cycle. Time taken for one complete wave cycle. Okay, that is small definition, right? Okay, then second point, write down the second point. It is measured by second. Measured by seconds. Okay, right. So international unit of the period is seconds. Right. Now we will come back to the again few definitions. So we will go and see about the frequency, then we will come back again to the period. Okay, right. So period we usually, okay, I will tell those things also here. Period also we represent by the capital T. We will represent it as a capital T. So what is the important formula we are going to build up here? So T, capital T equal 1 divided F. What is this? 1 divided F. F mean frequency. We didn't study that. So we will come back and see those things after finishing about the what? Yes, finishing about the frequency. Right. Now I will change these values. Then we will come back again here. Right. Now frequency. Frequency is how many complete wave cycles per unit time. That means per second. Okay, how many complete wave cycle form within unit time? That means per 1 second. So I will tell this. Now I am consider this from this to this. Okay, so I think here almost 2 wave cycle. Okay, so from here to here time duration is 1 second. Now the time duration is 1 second. Okay, so consider the time for all 2 cycles is 1 second. Now you can count how many cycles form within this 1 second. 2 cycles. So frequency is 2 cycles per second. Okay, so we can write down the frequency. Frequency equal 2 cycles per second. Okay, or we can tell 2 cycles per 1 second. Okay, this is way. So usually we are not telling the cycle, so we will remove this word here. So 2 per second, right? Okay, so simply we can tell it is now 2 per 1 second. Now it is, we can represent like this, 2 per second, right? So we will use a special unit for per second. The per second equal to hertz. Okay, that is equal to hertz. Now we can tell this is 2 per second, so that is equal to 2 hertz. Okay, that is equal to 2 hertz, right? Now, okay, you can understand. Oh my god, I wrote a little bit height near the right. I think now it's okay, right? So frequency 2 per second. Okay, 2 per second. So 2 per second, I wrote this like, so per second equal 1 hertz. Okay, right. So why I wrote 2 per second within 1 second time, 2 cycle. That means I wrote 2 cycles per second, right? So 2 cycle here. 2 cycle mean 1 test and 1 throw we consider as a 1 complete wave cycle, then another wave cycle. So 2 cycle. So how many cycles form within a unit time? That is a frequency, right? Okay. Now draw this one and write down these things under the frequency topic. Okay, under the frequency topic. Okay. Okay. Oh my God, is the time gone neither? How fast time going on? Right. Right. Okay. Right. If you're finished, please raise your hands. Okay, super. Right. Now we will move on to the next part. Okay. Then we will write down the definition. You have given three dotted line. So write down there. Okay. The number of wave cycles, the number of wave cycles, the number of wave cycle the number of wave cycle per unit time is called as frequency. Called as frequency. Right. The next point, the frequency is measured by hertz. Frequency is measured by hertz. So you can write down the unit hertz. H is a big H, is a small z. Okay, right. Okay, that is the hertz unit. Hertz. Okay, right, measured by the hertz. Right. Then another thing is, now we will come and look at about the another link. Okay, so now we will practice this one. Now I will give some scenario. Okay, now you understood about this. I hope you understood. Now, right. So from here to here, it taken 2 seconds, not a 2 second. It taken, yes, we will take 2 seconds. Okay. Now tell me the frequency. Now tell me the frequency. I need a frequency. What is the frequency? If you know the definition correctly, now you can answer correctly. Right. Okay. Tell me the frequency. For all this wave, it taken 2 second time. Now I am asking the, what is the, yes. 4 hertz. Now 4 hertz so here, yes, somebody telling 2 hertz. Okay, that's acceptable. But 4 hertz not acceptable. Why? Look at about Putha. Okay, I will again tell you. This is one wave cycle, right? Okay, this is another wave cycle. Okay, so this is one, this is two, second one. Okay, this is one wave cycle. This is another wave cycle. Okay, from here to here, right? Then I will take by the black color. This is another wave cycle, right? So three. So we have another one. So this is another wave cycle, right? So almost how many wave cycles are there? 4 wave cycles within 2 seconds. Now I am asking the hertz or frequency is how many wave cycles per 1 second, right? Per 1 second. So now 4 cycles or 4 wave cycles within 2 seconds. So now we can tell 2 for 1 second. Why? We can divide this 2 cancel here, then 2. So 2 wave cycle for 1 second. So 2 cycles, usually we are not writing that cycle terms. So 2 for 1 second. So we can represent that 2 for second. So we can write down 2 hertz. Okay. So wherever your text or you have a exercise book with you or your tute, wherever the spaces are available, you can write down this is a one example. Okay, don't worry. If your answer is wrong, don't worry. Now we can improve ourselves. Okay. එම තමා වැටි 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 තමයි නැකිටින්නේ. දැන් මේක වැරදෙනවා කියන එක හොඳයි. වැරදෙන්න ඕනේ. හැමදේම හරි ගිහිල්ලා හරියන්නේත් නැහැනේ. නේද? Right. Okay. Now okay. We will go for the another example. Okay. Right. Okay. Now correct. Now correct. Okay. Super. Now, okay, this finished. So we will go for the another one. Okay. Superb. Right. Okay, well done. So not identical here neither. එකක් ලොකු එකක් පොඩි. These days I am very suffering from the illness, so my hands are very shaky more. So අරවලන්න කෙලින් ඉරක් ඇඳ ගන්න බෑ. Yeah. Right. Okay. Now 1, 2, okay, 3 wave cycles are there. Okay. So I will give now I will give different way. Okay, not a different way. I will give here from here to here. It is taken 6 seconds. Okay, 6. Okay, now tell me what is the from here to here. These 3 wave cycles are there. So it's taken 6 seconds. So tell me the frequency now. What is the frequency? Okay. Okay. Most of you guys put the answers into the chat box. Okay. Right. 6 seconds for a 3 wave cycles. Okay, good. Right. Yes. Okay. Now, how many wave cycles here? One cycle. It's blue color one. Then this is another cycle. Okay, complete wave cycle. Then here another wave cycle, right? Okay. So all together 3 cycles. Okay, 3 wave cycles. Right. I will write down here 3 wave cycles. So what is the time? 6 seconds. 6 seconds. So we can divide that. So 3 divided 6 seconds. Okay. So for within 1 second, how much it should be? Within 1 nang me? How we can find out? Okay, you other way around you can go like this. Within 6 seconds, 3 cycles. So within 1 second, how many cycles? That is we are going to find out. So that means we have to divide this 3 by 6. Okay. So cycles. Okay. So within 1 second, 3 divided by 6, that means that is equal to 0. Okay, we can cut for that 1/2, that means 0.5. Okay, 0.5 cycles per second. That means the frequency equal, yes, frequency equal 0.5 hertz. Okay, all right. Now we have come to different scenario. Okay, different story. Okay, now altogether this is 6 seconds. So how much for one wave cycle? What is the time duration for one wave cycle? Altogether 3 wave cycles taking 6 seconds. So one wave cycle, one cycle, it is, yes, we can 6 divided by 3, it is 2 seconds. So this one cycle, 2 seconds. This another cycle, 2 seconds. Then another cycle, it is 2 seconds. So altogether it is 6 seconds. Okay, so that is the way how we can find out the period. Now we will build up something. This is frequency, all right. Ne? So if you have any mistake, if you make any mistake, you can correct now. So frequency is 0.5. Now this is the period. The 2 second is a period now. Okay, right. Now I will build a connection between these two. Okay, this is the frequency. So period here, period mean capital T. The frequency we are usually represent by the capital F, equal to second. Okay, the frequency 0.5 second, or we can tell it as a another way around. Yes, 0.5 per second. Okay, so all both are correct. Right. Now, what is the way? Now I will take, okay, 1 divided period. 1 divided period, take this 1 divided period. So 1 divided 2. So 2 seconds, right? So it will be give rise. Okay, what I did, I found out the period. Period is 2 seconds. So I will take 1 divided period here. So this side also, this is a equal mark. So I will take the period into the down, and this side the 2. So 1 divided 2. Here it also give rise. What is the value? Now 1 divided period will be equal 0.5 per second. Okay, so you can find out something. 1 divided period, it will be give the value of the frequency. So it will give me the value of the frequency. right? So if you know the period value, okay, now you can find out the frequency easily. So period we represent by the capital T, frequency is represented by the F. So we can build up the theory here. 1 divided T equal F. Okay, this is the frequency. This is given as a frequency. Okay, so 1 divided period, 1 divided T. So write down this formula in your frequency spaces or both spaces. Period කියන තැනත් ලියා ගන්න පුළුවන්. Then you can write down in the frequency area, right? Okay, okay, good, super. You all are interact. Neither. Okay, so 1 divided F. So I think I'm writing more up neither, right? Okay, I think now you can visible the screen, right? Okay, these are the things we should know. Okay, now simple another few examples. We will go through these formulas. Okay, no need to find out all together all those things, right? Oh no, all right, maybe kata una hari. Right. Okay, so this is given here. So now I will give time duration for this one. Okay, so time equal for one crest is 0.2 second. 0.2 second. Okay, so I don't know, can you guys visible? I will draw, I will write little bit large letters. Time equal 0.2 second for this one crest. Now I need the value of period. What is the period? Then what is the frequency? I will give 1 minute time to calculate and tell me. So these examples, please write down in your tute or wherever spaces you are available, or you can maintain a exercise books for these practical purposes. Okay, right. Okay, finish. So put the answers into the chat box. Okay, so I hope today class is very interactive, neither. So you are doing works and you are putting the chat box. So this is the way we should learn. We have time to we can complete all the syllabus at least twice. I mean, twice ඉවර කරන්න පුළුවන් December වෙනකොට. Okay, no hurry. But the thing is, a small thing, if you learn a small thing, that should be crystal clear. Right? Then no need to study before the exams. So you can sleep, get a very good sleep and go to the exams, and you can write down complete answers and you can easily score the A. Right? Okay, that's the answer. So my god, I just given the time period for one crest, this small crest, so that's 0.2 second. So what is the period now? Oh my god, why you are suffer? Why you guys suffer? It's okay. Okay, 0.5. What is that 0.5? Okay, look at here. The time duration for one wave cycle. So for one wave cycle, time duration for one wave cycle is equal period. So this is 0.2 for one crest. So one throw eකට 0.2. So altogether, so 0.2 plus 0.2, it will be 0.4 second for period. So period is equal 0.4 second. Okay, right, 0.4 second. Right. Okay. Then we have now the time duration for the small area I given, this small crest 0.2 second. Okay, right. This small area is 0.2 second. So this area also 0.2 second. So altogether from here to here, one wave cycle time duration is 0.4 second. Okay, so we can find out that. Then that is a period. Then how we can find out the frequency? So F equal 1 divided T. Simply we can find out that. Just now I told you. So F equal 1 divided T. So now we find out the T. T, that's the period, is the T, capital T. Period is capital T. So 1 divided T is 1 divided 0.4 second. Okay. So 1 divided 4, how much the value? Okay. 1 divided 4, how much the value? I'm very weak in mathematics. So tell me, guys, your answers. No answers. Oh my god, 1 divided 0.4. That is 2.5. Neither. Right. So that is 2.5. Right. So 2.5 per second. That is equal 2.5 hertz. Right. So this is the final answer. Right. So how many of you got that things? Okay. Right. Finish. So this is the simple understanding regarding the wave quantities, and we have another one quantity to understand. Okay, so we will finish that and we will discuss the other part of the electromagnetic part on another day, because today the time is not enough to complete all those things. Okay, right. So now we will come to the wave speed. Okay, right. Wave speed. I hope you finish these things. Neither. Right. Wave speed. Right. So speed of the wave. Right. So now we will take a formula for the speed. What is the speed now? Speed, usually how we can represent is speed is divided. Speed is equal distance divided by time. Right. So distance divided by time. So usual, that is a simple usual formula. Right. So now what is the distance for a wave? Okay. So I will consider the wavelength. Okay. Now the distance again මෙහෙම ගන්නකො. So මෙහෙම wave එකක් යනවා. Right. So මේ wave එකේ for this wave from here to here distance කියන එක එහෙනම් this is one wave cycle na, this distance equal to wavelength, or I can represent by the lambda. Okay, then time. Now time for this part, what is the time for this part? Okay, this wave is not much pretty. Okay, right, the time for this one wave cycle niputa, so the time is equal period. Period ni one cycle like time, this period, so capital T. So now I can tell the distance is wavelength. Now I can apply here the distance, that is a wavelength. Okay, so I can put lambda. Okay, right, lambda. Then the time time is period, or I can put capital T. Now, another scenario, okay? So usually we are represented by the capital V, okay? So that is the speed. Then we can write down speed. Usually we are represented by capital V. Now I can write down V equal lambda divided T. Then I will take this T separately, okay? Lambda, then 1 divided T. Okay, so in previously, few minutes ago, we discussed what is that 1 divided T equal F. This is another thing we learned before. So 1 divided T, now we have 1 divided T, so we can apply F. So we can apply here and we can write down lambda F. Okay, so V. Okay, so we will change the order. This is the formula, and we will change the order. V equal F lambda, right? So V is speed. Okay, this is speed of the wave. Then the F is frequency. Then lambda is wavelength. Now we able to build a formula. Okay, we had able to formula for the wave speed. So speed of the wave, right? So these are the things we can write down there. Okay, so I think you have spaces down over there. So before write down these things, so okay, then write down the definition part. Okay, you have spaces there. So write down the definition. Okay, so write down the speed at which wave propagate in a given medium. Okay, the speed at which wave propagate in a given medium speed at which wave propagates in a given medium represent as a wave speed. Represent as a wave speed. Right. Then write down these things. Draw this wave. The simply I taken the one length, one wave. I taken one wave cycle, single wave cycle. So distance I consider the wavelength is the distance. So the time duration for this one wave cycle, there's a period. Then I will take and apply here. Then it given a V equal F lambda. This is the final formula I am using for the calculation. So we will do this calculation in the next week or next day. Then it will be easy to understand what is going on there, right? Okay, so we can calculate any speed of the any given wave, right? Okay, then finish these things. Okay, then whoever finish, you have 10 MCQs there. Okay, in the page number 5, 10 MCQs. So please do that MCQs and we will discuss those MCQ in the next class. Okay, all right. We can finish these things and we will wind up today's session and we will see you guys tomorrow. Tomorrow, me. Ready? Right. Okay. So today, is that clear? Right? That clear all these things? Okay, sorry. I'm covered in this part. Ne? Right. Is that clear? Do you have any doubt? Do you have any suggestions? Right. Okay. So I need a very kind request. So I just gather some information from our participants. Nether. So most of guys from the Badulla and Gampaha, Kandy, and I think Akkare Pattu, nether. All guys all over the Sri Lanka, they are joining. So okay, so now the kind request is, so you may have friends, so you can join your friends to our classes. Then it will be helpful for me and you as well. So we can build a small group, and we can continue as this group class. Then I can continue it easily. So I am not expect to take more students because I can't look at about all of more students at the same time. So we will create a small group. So then we start the paid classes, next classes onwards. So ask your friends to join and tell your experiences, how this class is, or is it good or it's bad, or whatever the things you are feeling, you can share with your friends. Then if you feel what you feel, please put it to the chat box, to my chat box in the WhatsApp. Okay, WhatsApp, put it in the WhatsApp. Then it will be helpful for me as well. Okay, right. I think you got the idea about these things. So you not need to memorize these things. How we build up these things. This is the fundamental things. You should finally you should able to memorize, or you should able to write down this formula for the speed. V equal F lambda. That is enough. Okay. See you tomorrow. Tomorrow in my next class. Next week. See you. Bye. Okay.